Five eras are general purpose, mainframe and mini computer computing, personal computers, client or server networks, enterprise computing, and cloud and mobile computing. Technologies that characterize one era may also be used in another time period for other purposes. General purpose mainframe and mini computer era, 1959 to present. The mainframe era was a period of highly centralized computing under the control of professional programmers and systems operators, with most elements of infrastructure provided by a single vendor, the manufacturer of the hardware and the software. The introduction of the IBM 1401 and 1790 transistorized machines in 1959 marked the beginning of widespread commercial use of mainframe computers. In 1965, the mainframe computer truly came into its own with the introduction of the IBM 360 series. The 360 was the first commercial computer that could provide time sharing, multitasking, and virtual memory in more advanced models. IBM has dominated mainframe computing from this point on. Mainframe computers became powerful enough to support thousands of online remote terminals connected to the centralized mainframe using proprietary communication protocols and proprietary data lines. Image on the right shows the typical computing configurations characterizing each of the five eras of IT infrastructure evolution. Stages in IT infrastructure evolution. Personal computer era, 1981 to present. Although the first truly personal computers appeared in the 1970s, these machines had only limited distribution to computer enthusiasts. The appearance of the IBM PC in 1981 is usually considered the beginning of the PC era because this machine was the first to be widely adopted by businesses. Proliferation of PCs in the 1980s and early 1990s launched a spate of personal desktop productivity software tools, word processors, spreadsheets, electronic presentation software, and small data management programs that were very valuable to both home and corporate users. These PCs were standalone systems until PC operating system software in the 1990s made it possible to link them into networks. Client or server era, 1983 to present. In client or server computing, desktop or laptop computers called clients are networked to powerful server computers that provide the client computers with a variety of services and capabilities. Computer processing work is split between these two types of machines. The client is the user point of entry, whereas the server typically processes and stores shared data, serves up web pages, or manages network activities. The term server refers to both the software application and the physical computer on which the network software runs. The server could be a mainframe, but today, server computers typically are more powerful versions of personal computers, based on inexpensive chips and often using multiple processors in a single computer box or in server racks. The simplest client or server network consists of a client computer network to a server computer, with processing split between the two types of machines. This is called a two-tiered client or server architecture. Simple client or server networks can be found in small businesses. Most corporations have more complex, multi-tiered client or server architectures, often called N-tier client or server architectures, in which the work of the entire network is balanced over several different levels of servers, depending on the kind of service being requested. In this figure, it shows a multi-tiered N-tier client or server network. We have the client, internet, web server, application server, sales, production, accounting, HR, and the data itself. During the client or server era, novel netware was the leading technology for client or server networking at the beginning of the client or server era. Today, Microsoft is the market leader with its Windows operating systems, such as Windows Server, Windows 10, Windows 8, and Windows 7. Enterprise Computing Era, 1992 to present. In the early 1990s, American Standard Code for Information Interchange made it possible for computer machines from different manufacturers to exchange data. Common Business Oriented Language, or COBOL, an easy to use software language that greatly expanded the ability of programmers to write business related programs and reduce the cost of software. Unix, a powerful multitasking multi user portable operating system initially developed at Bell Labs. Ethernet, a network standard for connecting desktop computers into local area networks that enable the widespread adoption of client or server computing and local area networks. Transmission Control Protocol or Internet Protocol, suite of communications protocols and a common addressing scheme that enables millions of computers to connect together in one giant global network. IBM, Microsoft, Intel Personal Computer. The standard Intel designed for personal desktop computing based on standard Intel processors and other standard devices, Microsoft DOS, and later Windows software. World Wide Web. Standards for storing, retrieving, formatting, and displaying information as a World Wide Web of electronic pages, incorporating text, graphics, audio, and video, enables creation of a global repository of billions of web pages. Chapter 5-3. What are the current trends in computer hardware platforms? The exploding power of computer hardware and networking technology has dramatically changed how business organize their computing power, putting more of this power on networks and mobile handheld devices and obtaining more of their computing capabilities in the form of services. Here are 8 hardware trends. First, the mobile digital platform, consumeration of IT and BYOD, quantum computing, virtualization, cloud computing, edge computing, green computing, high performance or power saving processors. The mobile digital platform. It includes small, lightweight netbooks optimized for wireless communication and internet access, tablet computers such as the iPad, and digital ebook readers such as Amazon's Kindle with some web access capabilities. Smartphones and tablets are becoming the primary means of accessing the internet and are increasingly used for business computing as well as for consumer applications. Consumerization of IT and BYOD. What is BYOD? It means bring your own device. It is one aspect of the consumerization of IT in which new information technology that first emerges in the consumer market spreads into business organizations. Consumerization of IT includes not only mobile personal devices, but also business uses of software services that originated in the consumer marketplace as well, such as Google and Yahoo Search, Gmail, Google Maps, Dropbox, and even Facebook and Twitter. Quantum computing. It uses the principles of quantum physics to represent data and perform operations on these data. A quantum computer would gain enormous processing power through this ability to be in multiple states at once, allowing it to solve some scientific and business problems millions of times faster than can be done today. IBM has made quantum computing available to the general public through IBM Cloud. Google's Alphabet, Microsoft, Intel, and NASA are also working on quantum software as a service, platform as a service. For infrastructure as a service, customers use processing, storage, networking, and other computing resources from cloud service providers to run their information systems. Software as a service provides common business applications online. Users access these applications from a web browser, and the data and software are maintained on the provider's remote servers. Platform as a service, customers use infrastructure and programming tools supported by the cloud service provider to develop their own applications. Edge computing. This is a method of optimizing cloud computing systems by performing some data processing on a set of link servers at the edge of the network. Near the source of the data, this reduces the amount of data flowing back and forth between local computers and other devices and the central cloud data center. It reduces delays in the transmitting and processing of data because data doesn't have to travel over a network to a network data center or cloud for processing. Green computing. It refers to practices and technologies for designing, manufacturing, using, and disposing of computers, servers, and associated devices such as monitors, printers, storage devices, and networking, and communication systems to minimize impact on the environment. Large companies like Microsoft, Google, Facebook, and Apple are starting to reduce their carbon footprint with clean energy powered data centers with power conserving equipment and extensive use of wind and hydropower. Did you know? According to greenhouse data, the world's data centers use as much energy as the output of 30 nuclear power plants, which amounts to 1.5% of all energy used in the world. High performance and power saving processors. Another way to reduce power requirements and hardware sprawl is to use more efficient and power saving processors. Contemporary microprocessors now feature multiple processor cores on a single chip. Intel and other chip manufacturers are working on microprocessors that minimize power consumption, which is essential for prolonging battery life in small mobile digital devices. Chapter 5-4. What are the current computer software platforms and trends? There are four major themes in contemporary software platform evolution: Linux and open source software, Java, HTML, and HTML5, web services and service oriented architecture, software outsourcing, and cloud services. Linux and open source software. Open source software. It is produced by community of programmers. It is free and modifiable by user. Examples are Apache Web Server, Mozilla Firefox Browser, OpenOffice. Linux. Open source OS or operating system. Used in mobile devices, local area networks, web servers, high performance computing. Software for the web. We have Java, HTML, and HTML5. Java is an operating system independent, processor independent, object oriented programming language created by Sun Microsystems that has become the leading interactive programming environment for the web. HTML, which means hypertext markup language, a page description language for specifying how text, graphics, video, and sound are placed on a web page, and for creating dynamic links to other web pages and objects. Using these links, user need only point at the highlighted keyword or graphic, click on it, and immediately be transported to another document.
HTML5. It is the latest evolution of HTML and solves the problem in making possible to embed images, audio, video, and other elements directly into a document without processor-intensive add-ons. Web services and service-oriented architecture. Web services refer to a set of loosely coupled software components that exchange information with each other using universal web communication standards and languages. They can exchange information between two different systems, regardless of the operating systems or programming languages on which the systems are based. XML, which means Extensible Markup Language, it is developed in 1996 by the World Wide Web Consortium. It can perform presentation, communication, and storage of data. A service oriented architecture, or SOA, is a set of self contained services that communicate with each other to create a working software application. Business tasks are accomplished by executing a series of these services. Software developers reuse these services in other combinations to assemble other applications as needed. Here are examples of XML. In plain English, it's just a specific word, such as subcompact. But in XML, and availability of mission critical systems. Management and governance. Here are some questions. Who controls IT infrastructure? How should IT department be organized? It could be centralized or decentralized. In centralized, central IT department makes decisions. Decentralized, business unit IT departments make own decisions. How were costs allocated between divisions and departments? Each organization will need to arrive at answers based on its own needs. Making wise infrastructure investments. Amount to spend on IT is complex question. You have to consider renting versus buying, cloud computing, outsourcing, total cost of ownership or TCO model, analyzes direct and indirect cost, hardware or software account for only about 20% of TCO, other costs that needs to be considered, installation, training, support, maintenance, infrastructure, downtime, space, and energy. TCO or total cost of ownership can be reduced. Use of cloud services, greater centralization, and standardization of hardware and software resources. Competitive forces model for IT infrastructure. There are six factors you can use to answer the question: how much should our firm spend on IT infrastructure? Number one, market demand for your firm's customer services, supplier services, and enterprise services. Number two, your firm's business strategy. Number three, your firm's ID strategy, infrastructure, and cost. Number four, information technology. Number five, competitor firms' IT services. Number six, external market factors. To summarize the discussion, IT infrastructure is the shared technology resources that provide a platform for the firm's specific information system applications. The five stages of IT infrastructure evolution are the mainframe era, the personal computer era, the client or server era, the enterprise computing era, and the cloud and mobile computing era. Major IT infrastructure components include computer hardware platforms, operating system platforms, enterprise software platforms, networking and telecommunications platforms, database management software, internet platforms, and consulting services and systems integrators. In terms of current trends in computer hardware platforms, increasingly, computing is taking place on a mobile digital platform. And at the end of the day, there will always be challenges in managing IT infrastructure and determining what could be your management solutions. Major challenges include dealing with platform and infrastructure change, infrastructure management and governance, and making wise infrastructure investments. Solution guidelines include using a competitive forces model to determine how much to spend on IT infrastructure and where to make strategic infrastructure investments, and establishing the total cost of ownership of information technology assets. Thank you, and I hope you learned something from today's topic. Have a great day!